Network traffic appears to be a single, undifferentiated stream of data moving between a client and a server. In practice, a modern network is a segmented environment where diverse services operate simultaneously across shared physical hardware. This traffic is governed by a strict architecture of protocols and port numbers, designated logical gates that ensure data reaches the correct application without collision. To understand how this architecture organizes raw data, we can trace a single linear network transaction from start to finish. This trace follows the data from the initial client connection and secure web delivery through to back-end email routing and administrative management. Mapping this interconnected flow provides the technical blueprint required to provision and maintain modern network services. Before a client can send a user payload, the network must establish a logical infrastructure matrix. The client device must first obtain a unique logical address. It broadcasts a request to a dynamic host configuration protocol server to secure an IP address, utilizing UDP port 67 for the server and port 68 for the client. Once the address is assigned, users typically navigate via URLs, but network hardware routes traffic strictly using these IP addresses. The client must then query a domain name system server to translate that human-readable domain into the server's specific IP address. This name resolution process operates over port 53 and is one of the few services to utilize both the TCP and UDP protocols. DHCP and DNS act as the prerequisite foundation for the network. Without them, higher-level application services cannot function. With the IP address resolved, the browser can finally request the web page content from the host. Legacy web traffic communicates using the Hypertext Transfer Protocol on port 80. The primary risk of port 80 is that data is sent in unencrypted plain text, allowing traffic to be intercepted and read by unauthorized third parties. Modern web standards instead utilize HTTPS on port 443. HTTPS uses transport layer security encryption to protect data confidentiality. It relies on public and private key pairs to authenticate the server and secure logins or payments. Moving traffic from port 80 to port 443 establishes the minimum security baseline for protecting sensitive user data on the web. If a user interacts with a web form, it often triggers a back-end email notification. Outbound email goes to a mail server using SMTP on port 25. The system checks mail exchanger DNS records to identify destination servers. To retrieve messages, clients use POP3 on port 110 or port 995 for secure SSL. POP3 downloads the email to the local device and usually removes the original copy from the server. Modern environments favor IMAP on port 143 or 993 for secure connections because it synchronizes email state across multiple devices while retaining the data on the server. The email transaction relies on these three distinct mechanisms, each mapped to its own port for sending, resolving, and retrieving data. Beyond the user's data flow lies the administrative control room used to oversee the health of these services. Sustaining these transactions requires constant telemetry and remote configuration by IT professionals. Administrators use the simple network management protocol over ports 161 and 162 to monitor device health. They also utilize syslog on UDP port 514 to aggregate event logs. For direct configuration, Secure Shell on port 22 provides encrypted command line access to remote servers. If a graphical interface is required, the Remote Desktop Protocol provides full desktop control via port 3389. Legacy protocols like FTP or NetBIOS, along with unpatched IoT devices, often lack these modern management hooks, creating significant security gaps in the network. The management plane provides the visibility and control necessary to audit health and configure remote resources across the entire network. Mapping these specific ports and protocols provides a structured framework for diagnosing service failures. When a critical network service suddenly fails, having this structural knowledge allows administrators to perform a systematic isolation of the root cause. The standard troubleshooting methodology begins by verifying the physical layer before investigating protocol settings. Issues like port flapping or complete connectivity loss often trace back to damaged patch cords or duplex speed mismatches between the network interface and the switch. If the physical connection is stable, the investigation moves to the logical layer, checking for network congestion or failures in DNS resolution on port 53. The final step involves verifying application layer configurations, such as a firewall blocking port 443 for web traffic or port 25 for email. Network services operate deterministically. By isolating a symptom to its specific port and protocol, administrators can identify the root cause and restore the flow of data.